Second law of reflection of light. Second law of reflection of light states that the incident ray, the normal at the point of incidence, and reflected ray all lie in the same plane. For example, in this ray diagram, the incident ray AO, the reflected ray OB, and the normal ON all lie in the same plane. Shall we perform an experiment to understand how we get the laws of reflection? Take a white sheet of paper and fix it on a drawing board or a table. Take a cardboard and cut a eye slit along one of its walls. Now hold the cardboard perpendicular to its sheet of paper. Now throw the light from a torch through the opening of the cardboard from one side. With slight adjustment of the torch and the cardboard, you will see a ray of light along the paper on the other side of the cardboard. Keep the cardboard and the torch steady. Place a strip of plain mirror in the path of the light ray. What do you observe in this experiment? We see that after striking the mirror, the ray of light is reflected in another direction. Now draw the lines showing the position of the plane mirror, the incident ray, and the reflected ray on the paper. Remove the mirror and the cardboard. Draw a line making an angle of 90 degrees to the line representing the mirror at the point where the incident ray strikes the mirror. Now, measure the angle of incidence and the angle of reflection. Repeat this activity by changing the angle of incidence. What do you observe when you change the angle of incidence? Angle of reflection also changes as we change the angle of incidence. Do you find any relation between the angle of incidence and the angle of reflection? Are they equal? By repeating the experiment, we see that the angle of incidence is always equal to the angle of reflection. This is known as the law of reflection. Let us find out what would happen if we throw the light on the mirror along the normal. A light beam falls on the surface of a flat mirror along the normal. The angle of incidence is 0 degrees. Hence, no bending will occur and the ray of light propagates undeviated from one medium to another. Take a chart paper and place it on a table in such a way that the sheet projects a little beyond the edge of the table. Cut the projecting portion of the sheet in the middle. Take a light source like a torch. Place the cardboard with a hole in the path of light source. Now throw a light beam on a reflecting surface like a mirror placed on the chart paper. The light after striking the mirror will be reflected. The reflected ray extends to the projected portion of the paper. Bend the part of the projected portion of paper where the reflected ray falls. Can you still see the reflected ray? No, the reflected ray is not visible on the bent sheet of paper. Now again bring the paper back to the original position. Check now if you see the reflected ray again? Yes, the reflected ray is visible again when we bring the paper to its original position. So we infer that incident ray, reflected ray, and the normal at the point of incidence lie in the same plane. We can explain the above phenomenon as given here. Where the whole sheet of paper is spread on the table, it represents one plane. So the incident ray, the normal at the point of incidence, and the reflected ray all lie in this plane. Hence, we are able to see the reflected ray. But when you bend the paper, you create a different plane. Now at this time, the incident ray, the normal at the point of incidence, and the reflected ray all do not lie in the same plane. At this time, we are not able to see the reflected ray. So ultimately, we are able to give explanation for the second law of reflection, which states that the incident ray, the normal at the point of incidence, and the reflected ray all lie in this plane.